Good evening. My name is HAMSAMUNNIsh. This is my partner.
Hi, my name is LINGESWARAN ANBARASAN. For this our project, our supervisor name is this SHAFIZAH BINTI SHAFIAL at SHAFII. So our project name is Pyrolysis of Plastic Waste to Crude Oil. We are students from the Civil Engineering Department at Politeknik Tuanku Sultanah Bahiyah Kulim.
So, introduction. The production and consumption of plastic waste is increasing at an alarming rate. With the increase in human population, rapid economic growth, continuous urbanization, and changes in lifestyles, plastic production is estimated at around 300 billion tons per year. Disposal of plastic waste in landfills provides a habitat for insects and rodents, which can cause a variety of diseases. The pyrolysis process is the choice of waste energy technology to deliver biofuel to replace fossil fuels. The advantage of the pyrolysis process is its ability to handle dirty plastics. Pre-treatment of the material is easy. Plastics need to be sorted and dried. The pyrolysis process is also not a dangerous smoke emission process and is not environmental pollution because it is a closed combustion process to help the waste recycling process.
Important of study for this project is this. Pyrolysis-based biofines have great potential to convert waste such as plastic and biomass waste into energy and other valuable products. Can produce renewable energy sources such as plastic pyrolysis, oil, carbon black, and combustible gas. It has the characteristic of high efficiency, low consumption, and high oil yield. To reduce waste, plastic pyrolysis plant can return non-condensing gas to the reactor of the plastic pyrolysis plant to assist fuel combustion and save fuel.
Okay, this is our project prototype. We use a gas, we connect the gas to the stove, and we use a high heat resistant tank as furnace. And we use an iron rod between the furnace and the bucket, which is filled with water. Okay, this iron rod will transfer the gas from the furnace to the bucket to form the crude oil, and the size of the furnace is 26-liter capacity, 0.5 mm thickness, 406 mm height, and 320 mm diameter.
First of all, we have an empty gas tank as a furnace in which we are going to melt the plastic. Okay, through the process, 1 kilo of plastic yield equals to 500 milliliter of oil. So we use 2 kilo of plastic waste to get 1 kilo of 1 kilo or 1 kilogram of oil. Okay, the type of plastic used are PET, PP, HDP, PS, and other like ABS, nylon, and PC. We use iron tank can withstand temperature above 450 Celsius. In our second experiment, the tank we used was made of iron with a higher thickness than can we use in our first experiment. This process occurs in the absence of oxygen. In this design, actually, we cut the empty gas by half to fill the plastic and ties into it. We have this condenser pipe in which we have a cooling chamber. This cooling chamber is made of stainless steel PVC pipe. Now, after the condensation, these pipes take the condensed oil into the collection chamber. In this collection chamber, we will get the crude oil that we can use later by processing for different purposes.
Okay, as you can see in this video, there are bubbles coming out from the water. These bubbles contains oil molecules. When the bubbles burst, the oil molecules will float on water because oil less dense than water. Okay. This is the way we use to extract oil from the water. we use a ladle to extract the oil from the water, and we try to lit up the oil. Successfully, it lit up until 1 minute and 20 seconds. So the process pyrolysis plant for plastic waste to crude oil conversion offers an innovative and sustainable solution to address the plastic waste crisis. By transforming plastic waste into a valuable resource, the project contributes to waste reduction, energy generation, and environmental preservation.
Okay, the test result that have been obtained through experiment in the laboratory. The readings for each experiment carried out will be taken from various items to get the average reading and to get the reading obtained consistently or not. The tests that have been carried out are pH level, flash point, density, sulfur, ash, water, and kinematic viscosity test.
Okay, the pH value, we get a 2.28. Okay, a solution with a pH of less than 0 till 6 is considered acidic. So our crude oil is a acid oil. So next is flash point. We get 14 Celsius. Okay, a liquid is considered to be flammable if its flash point less than 60 Celsius. And then density at 15 Celsius, we get 0.93 kg per meter cube. The density of crude oil will range between 700 to 950 kg meter cube. So our range is between 700 to 950 kg meter cube. So next is sulfur. Sulfur percentage, we get 0.28. Okay, crude oil is defined as sour if its sulfur content exceeds 0.5 percentage. Okay, sour crude is a type of crude oil known for its relatively high sulfur content. The presence of sulfur makes oil more difficult and costly to refine. So by contrast, sweet crude oil is known for its low sulfur content and commands a higher price on international commodity markets. So our crude oil is considered as a sweet crude oil. Okay, next is ash. Ash percentage, we get ND smaller than 0.1. Okay, typically the ash value is in the range of 0.03 till 0.07 percentage. Kinematic viscosity at 20 Celsius, we get 5.91 reading. Okay. Light crude oil API gravity higher than 31.1 Celsius API less than 870 kg per meter cube. Okay, and then last is water content percentage. Okay, water content percentage, we get 0.58%. Okay, crude oil contains different amounts of water and sediments. As water can induce corrosion during the refinery process, crude oil must not contain more than 0.5 to 1% of water. Next. Okay, conclusion. The advantages of pyrolysis of plastic waste to crude oil are significant. By converting plastic waste into crude oil, we can effectively repurpose the waste and decrease the strain on traditional waste management systems. Secondly, the crude oil obtained from pyrolysis can be used as a valuable energy source into various petroleum products such as gasoline, diesel, or even used a feedstock in the petrochemical industry. This reduces the dependency on fossil fuels, contributes to energy security, and promotes a more sustainable energy mix. The process requires careful control of operating conditions, including temperature, pressure, and residence time to ensure efficient conversion and minimize the release of harmful byproducts. Additionally, the quality of the crude oil obtained from pyrolysis may vary depending on the types and composition of plastic waste used. The implementation of large-scale pyrolysis plants requires significant investment, and the cost-effectiveness of the process depends on various factors such as feedstock, availability, energy requirements, and market demand for the end products. In summary, while pyrolysis of plastic waste to crude oil offers a promising solution for plastic waste management and resource recovery, further research, technological advancements, and supportive policies are needed to address the challenges and ensure its widespread adoption as a sustainable waste management strategy.
Okay, our project can recommend by two recommendation. Okay, first recommendation is quality control. Okay, establish rigorous quality control measure to ensure the consistency and compliance of the crude oil produce. Regular testing of the crude oil for properties such as viscosity, density, sulfur content, and calorific value will help meet industry standard and facilities its successful commercialization. For recommended two is market and product development. Conduct market research to identify potential buyers and establish partnership for the sale and distribution of the crude oil and derived product. Explore opportunities for collaboration with refiners, chemical manufacturers, or energy companies to enhance market access and create value added product.